Now we're going to find the stationary points of our function g of t. We need to find our stationary points first and then determine their nature. So our first step when finding a stationary point is finding when their derivative is equal to 0. So now we're going to find our derivative, our g prime of t, is going to be equal to 3t squared minus 18t plus 27. And remember, the 19 at the end here just disappears because it doesn't have a function of t. To find a stationary point, we need to solve when this is equal to 0. So 0 equals 3t squared minus 18t plus 27. Now we have a common factor of 3 in each one of these, so we're just going to go ahead and divide the whole thing by 3, which gives us t squared minus 6t plus 9. Now we can solve this part here by completing the square. What numbers multiply to give us 9? Well, that's 1 and 9 and 3 times 3. 3 plus 3 will also equal 6. So our function here will be t minus 3 squared. Now we just need to solve our equation to find a value of t that is going to make our equation equal to 0. Well, in this situation, the only value is going to be when t is equal to 3, because then we have 3 minus 3 is going to be equal to 0. Now we're going to find what our actual stationary point is. So we're going to put our value of t back into our original equation. So our g of 3 is going to equal 3 cubed minus 9 times 3 squared plus 27 times 3 minus 19, which, solving that, gives us a value of 8. So this means that we have a stationary point at the point 3, 8. Now we just need to determine the nature of our stationary point, and we do that again by just drawing up our tables. So now let's just put together our graph. Then we just put in our stationary point, so our g prime of t in this situation, and that just is going to be equal to 0. Now we're just going to begin by looking at a negative point, so our g prime of t minus h. And looking at our derivative up here, we've got a 3t squared, a minus 18t, and a plus 27. So if we just choose when t is equal to 0, our first term and our second term are not going to be there anymore, and we're only going to have our last term. So it's going to be a positive value, which means our graph is going to go up. Now we need to look at a point that's further along than our stationary point, so our g of prime of t plus h. Picking a point that's greater than our stationary point, so when t is equal to 3, a nice easy one to use is when t is equal to 10. So if we do 10 squared, well, that's going to be 100 times by 3, 300. 18 times 10 is going to give us 180. And we're just going to add 27. So if we've got 300 minus 180 plus 27, that's going to be positive as well. So that means that it has another positive gradient. And in this situation, we have a point of inflection. As the gradient before and after our stationary point are both positive, we have a point of inflection rather than a minimum or a maximum. Now let's look at this on the graph. Well, our point 3,8 is here. And we can see that on the graph, it has a positive gradient that slows down till our stationary point, and then it has a positive gradient afterwards, slowly getting steeper as it goes away from our point.